Hey everyone, I'm going to go ahead and get started. I see people are still coming in, leaving, that's fine. We're a little behind schedule, so I may be moving a bit quicker than normal. So this is Defense in Depth Engineering. This is a security talk. Hope everyone's excited for security. Show of hands, anyone here do security full time? No one. Well, you all are doing security in one way or another. This talk, fair warning, we're going to be looking at some code. We're going to be looking at a bunch of different concepts in application security. I should be available for a bit after this talk, but I don't know if I'll be around the conference tomorrow. I have to travel back home pretty early. So feel free to get in touch with me after the conference tonight or on LinkedIn. I'm happy to answer any questions. And to that regard, this is a workshop track, which means this talk is going to be a little bit interactive. I'm going to be asking questions. I normally give this in an 8-hour training workshop where people are coming hands-on, writing code, fixing security issues. I normally make that available for free. So if you're interested in that type of variant, reach out to me and I'll get you the content for that and you can kind of run through some of that on your own. So brief outline here. We're going through an introduction now. There's 4 primary pieces of technical content: designing for incidents, preventing regression, designing for extensibility, and then understanding your libraries. And then at the end, with enough time, we'll wrap up and hopefully it makes sense. The talk was designed this way for a very particular reason, which I think will make sense as we move forward. So a little about myself, John Poulin. I'm from Maine, so it's about 5.5-hour drive to get here. First time in Montreal, it's been great. Currently CTO of a security consulting company called Cloud Security Partners. Before that, I was a manager of product security at GitHub. Who uses GitHub? All right, a couple hands at least, that's good. Last time I gave this talk was for a college class, and half of them had never used GitHub before, so this is a little more promising. So while I was at GitHub, I ran teams that managed product and application security. So we made sure the code that GitHub was writing was secure. We wrote secure requirements for coding, so things like which libraries to use or which ways to interact with a database safely. We solved problems like that. It was obviously a lot more complicated than how I'm talking about it now. And then before that, I was a consultant. So I got paid to hack people, hack customers, did a lot of fun, doing that. Anyone here use Royal Bank of Canada, RBC? Okay, I've done some work for them. I can't share any stories, but yeah, that was a fun customer. Financials are always fun. When you realize how much is at stake there, whew, scary. And before that even, I was a software engineer. So I wrote the code that was vulnerable, the code that was being hacked. So show of hands, who here has ever been part of a security incident? Okay, who here has caused a security incident? At least 1 or 2 honest people. Yeah, I've been on both sides. I've caused security incidents. I've been involved in mitigating them. We're going to talk a little bit about some of that stuff. So in 2021, OWASP, which is open worldwide application security project, they released a standard for insecure program design. OWASP is kind of the go-to open standard for all things related to web application security. And we've been dealing with the OWASP Top 10 for 20 years at this point. This is the #1 place to look to for information related to secure web development. And so it took them until 2021 to design a category for insecure design, because at the end of the day, a lot of the problems we're seeing in the industry now and across our customers are no longer secure vulnerabilities in code such as SQL injection, but the problem is the way the application was designed and architected to begin with has inherent faults. And so we released the insecure design, which basically calls for more threat modeling, more architecture design, things like that. Has anyone ever done any threat modeling before? Maybe I should have gave a threat modeling talk instead. I'll try to come back next time and give a threat modeling workshop. Those are fun. I gave a threat modeling workshop for a non-technical audience recently where we learned how to threat model homes and castles and layer on defenses and understand the attacks and the attackers. So it's a fun exercise to do. So we have insecure design. People are paying attention to it now. More often than not, the work I'm doing on a day-to-day basis is helping folks design their applications, their architectures more securely. What is defense in depth? Okay, well, so this is a pretty common concept in military. The general idea is that applying more layers onto a problem will help make it more secure by default. So there's a pretty big definition in there. I'm not gonna read over it in too much depth, but these are controls that are often overlooked when we're all frantically building our application. We may be not thinking about our logging infrastructure, for instance, but they are things that are a lot easier to solve when we're designing the application before we actually start writing the code. So these are some of the ideas that we're going to be talking about here. And this is the obligatory security onion. If you hang around with security folks long enough, we'll start talking about the security onion. That's basically just throwing another layer of protection on it. At lunch today, we had a conversation about multi-factor authentication and being asked to re-MFA auth every 5 minutes or something like that. Well, that's a layer of defense, right? Defense in depth right there. So the first thing we're going to talk about is designing for incidents or becoming friends with your incident response team. So as we're building and designing these systems, we really want to start by understanding what is the risk of the system. What type of data exists in the system? Are we handling billing information, personally identifiable information? If so, where is that going to go? Is this data documented? So who here works on systems that handle let's say user addresses, a physical address? Anyone dealing with that type of stuff? We got a couple hands. Now, if an incident responder came to you and said, hey, we heard that our application was leaking user addresses on the internet, like, would you know where to find those? So these are the types of things we're talking about here, documenting where that sensitive data lives and the systems from within which it flows. And this is when things like data flow diagrams come into play. So data flow diagrams showcase, different systems, the data flowing between them. Super important to have accountability of the data we're dealing with, particularly the sensitive data. So building a plan of action, obviously this is not everyone's first step. So when you're engineering systems, when you're designing systems, start to think about what you're going to need to do from a logging perspective so that when your incident responder comes to you and says, hey, we're leaking data, you know how to actually go out and find where that data leak is. What data, for instance, should we be logging? Anyone think of an example of data that should generally be logged? I learned earlier I'm supposed to wait 10 seconds before I answer. So, yeah, logging errors, that's a good idea. So anytime your system throws an exception, you probably want to log that, probably want to log some context. What about user IP addresses? Should we be logging those? I'm hearing some mixed answers there, and generally that's going to be one of those it depends cases. More often than not, you do want to log IP addresses. There are some restrictions to that, and there's some caveats there as well. For instance, do you want to log the IP addresses of your staff users? Maybe, maybe not. So, it's one of those things where having a plan ahead of time before you actually start building the system allows you to put these types of filters in place. Now, what's an example of data that should not be logged? Passwords? I heard someone say passwords. Yes, good answer. I'm working with a customer right now that has been logging passwords for a long time now, and it's quite concerning to me. Obviously, I'm not going to tell you who they are, but we have to have a chat. How long should your logs live? What thoughts do you have about that? It depends, yeah. So generally speaking, 7 to 14 days, if not more. Shopify, for instance, their logs only live for 14 days. So if you're performing an incident response, you need to go back a month. You're not going to have access to those logs. So you kind of need to know ahead of time. And then, of course, costs are always a factor with log storage. So in the event of a security breach, you need to know where your data is being stored. You need to know what you're logging. But what are your expectations from engineering leadership, for instance? Are you going to be expected to be in a war room, maybe 3 in the morning, trying to frantically figure out where the vulnerability is, trying to frantically fix it? Design a playbook, have a playbook ready, and understand whether or not you're going to be expected to be communicating with senior leadership, for instance. Because bringing a junior engineer into a war room and then expecting them to communicate with the CTO of the company, that's going to put a lot of pressure on them. But if they know ahead of time, that's something they can prepare for. So public communication is the other big one. Are you going to have to release something publicly? This changes things quite a bit. So I want to give you an example. Being prepared to own the outcome is super important because at the end of the day, we're all in business because we have customers. Customers like to use our product. They pay us for our product. We need to communicate with them. So I like to share this example of owning the outcome because when I was at GitHub, thankfully I was actually on PTO during this incident, so I didn't have to deal with it. But in, I think, March of 2021, we logged out every single user from github.com. Did anyone notice that or remember that at all? So people notice. That's the type of event that, folks start talking about, hey, did you get logged out of github.com? That's never happened to me before. So you have to own the outcome. And so this blog post is amazing engineering blog post. Highly recommend checking that out because it talks about how we trace through this very technical, I don't even want to consider it a vulnerability, but a very technical bug. And at the end of the day, we forcefully logged out every single one of github.com users, which, by the way, that does not happen in an order of minutes. This happens in an order of hours, if not longer. That's a lot of transactions. And we felt good about knowing that our users were safe because their sessions were no longer valid. The crux here is that this was a session swapping type of bug where there was a concurrency mechanism in the rack web server which had a bug allowing user sessions to be swapped. So you'd be logged into your account, load another page, and then suddenly you're in someone else's GitHub account. Terrifying, but not something that could have been forcefully exploited. This was kind of a luck of the draw type of situation. So we just decided, we're going to log everyone out just so we're not experiencing that, fix the issue. We own the outcome there. And again, I was on PTO, thankfully. I was also on PTO for Log4j as well, so I have a pretty good trend on taking PTO. So early on, just recognize investigations, security incidents, they're going to happen. Focus on building out that playbook so you know how to handle them. Build employee trust by focusing on a blameless post-mortem. Whenever an incident happens, you don't want to grab the person who you think was responsible and start yelling at them or asking them, why it happened. What you want to do is you want to work with the team who maybe owns that product area to figure out what the source of the vulnerability is. This is no different than an availability incident. If your site goes down, you don't want to come yelling at people, right? So no different here. Just take a breath, work as a team. We've had a lot of fun in war rooms using it as a team building exercise, believe it or not. And always keep in mind, you got to support your customers. That's why we're here. And customers have incidents too. So when a customer has an incident, they're going to have some questions. So let me frame this in a particular way. So GitHub has integrations. We had personal access tokens, GitHub apps, OAuth apps, many ways that our customers could integrate with us, and also many ways that a customer could lose their own credentials. And so occasionally support would get a request, hey, so-and-so from this enterprise organization had their account compromised. Can you help them investigate to figure out what happened? What did the threat actor do with their account? And generally, we got to the point where we said, no, we can't do that because we're doing this 5 times a week, every week. We need to build a system. And so we started introducing audit logs. So self-service logging so that users could go in themselves, identify, hey, what happened on my account, and start to answer those questions themselves. And this allowed us to get away from the customer response side of things and build an engineering process to encapsulate the questions that the user was asking. So, things like what data was accessed, when was it accessed, how was it accessed, who here has looked at audit logs before on GitHub or a similar system? Oof, I'd like to see more hands. Y'all should be checking out your logs more often then. Bad stuff happens all the time. But as you imagine, when you start telling people, hey, we have these logs for you, these answer all your questions, the moment that there's a gap in the logging coverage, the moment the customers aren't going to be happy. So, oh, you can only tell me, 50% of the things that happened. What about the other things that you're not accounting for? So generally speaking, you need to build a logging playbook or logging infrastructure to encapsulate everything because we want to have full coverage. So ensure every state-changing request is audited. Okay, who here is a Ruby on Rails developer? Hey, my people over there. So basically what we're looking at here is in Ruby on Rails, there's an application controller, which is generally the controller from which everything inherits. And we've defined an after-action method, which runs after every controller would execute. And then we're basically looking at it and saying, hey, if we audited this request in some way, we're good to go. But if not, we're going to return an exception. And we're only doing this for what I consider state-changing requests. So post requests, put requests, delete requests. Thankfully, Ruby code's generally pretty easy to read, so I'm guessing y'all can make some sense of this. But the idea here is at the middleware level, we've introduced a checkpoint that says, before we send this request back to the user, or before we send the response back to the user, we want to make sure this went through some auditing. We want to make sure we have a record of all the things that happened in case they ever need to review it. So that's an attempt at doing exactly that. And this pattern works pretty well for the most part. But there's a couple problems. So we can improve that. And by the way, the source code that you're seeing up here is available on GitHub. If you message me after, I can send you the link. My X handle's down there. You can find me via email, find me on LinkedIn. But the idea here is we have this concept of an audit log entry, and we want to make sure we're omitting those whenever some state changes happen, such as when we're destroying a user's shopping cart, for instance. Sounds like the type of thing a user would want to know happened on their account. And then over here, we just have some logic to actually emit that request and to perform that logging. So one last thing I want to call out here, audit logs are extremely important, and the fact that only a few of you raised your hands for looking at them is a little bit concerning to me. I would love to have you all focus on reviewing your audit logs more often. I check audit logs for GitHub, I check audit logs for Gmail very regularly. But what this is here is this is an audit logs wall of shame. A lot of enterprise solutions now have started implementing audit logging, and they either lock it behind a paywall or require some sort of enterprise support plan. So what you could do is you could check out this auditlogs.tax website, view a list of all the services and providers that are not making audit logs freely available. And then if you're in a purchasing decision when you're evaluating software, you can look here and say, okay, are we actually going to be able to use this to investigate our security problems? Because if not, maybe that's a reason to look at a different piece of software. And if you're not building audit logging into your own software, you definitely should start doing that. So audit logging is useful when there's incidents or investigations. Now, the other thing that happens with an investigation, we want to make sure it doesn't happen again, right? So preventing regression, never wasting a good incident. So how can we prevent regression? So when I say regression, what I mean is we want to make sure the same problem doesn't happen again. Code regresses sometimes. There's merge conflicts and we don't resolve them properly, so our vulnerability gets reintroduced. So the way we prevent regression, simple three-step process. Start with root cause analysis during the incident response process to understand what the actual problem was. If we're talking about a SQL injection vulnerability, We know the problem is that user data was intermingled with the SQL query, and that led to an attacker being able to execute SQL on behalf of our database. Okay, we got that straightforward, we can fix it. Then perform variant analysis. So once you understand what the original problem was, think about what other variants of that could exist in your system. With SQL injection, we've known about SQL injection for 20 plus years now. Not as likely to find variants, but maybe you've discovered a new vulnerability that you weren't aware of. Has anyone heard of server-side request forgery, for instance? A few folks, right? But in terms of web application vulnerabilities, this is newer, especially so in the last 5-ish years. So maybe you discovered server-side request forgery vulnerability, you understand it now, perform variant analysis to find other areas in your application where you could be vulnerable. And then using tests to prevent regression. This is the big point here. All right, so who's ready for a test? Last talk of the evening, I think everyone's ready to go home. Okay, so this is the test. What is the goal of this test? And I will wait at least 10 seconds. I hear people quietly chattering. So it's testing a file upload vulnerability. Well, the vulnerability is actually not a file upload vulnerability. It exists in a file upload system. But what vulnerability in particular are we testing for? So line, I think 21 there. Does anyone recognize that? What would we be using that for? Well, this is a command injection string, and what we're doing is we're testing for a command injection vulnerability. So in this case, this is actually an open source Ruby on Rails application designed to be intentionally vulnerable. But there's security tests inside the application that illustrate some important concepts. So we're testing for command injection vulnerability by inserting things that look like Unix commands, and we want to see how the application responds to those. So in this case, our payload, as we call it, the bad thing we're trying to do is changing directory twice and then removing all of the contents of the directory. And the idea here is if the application is not vulnerable, nothing's going to be deleted. So that's fine. But like most things, I have some opinions on how this should be done. So generally speaking, we want to use unit testing whenever possible. This is an integration test. It's fine in this particular case. What really kind of grinds my gears here is the test is deleting data. This causes some problems. So if we consider alternative payloads, we could instead try to run like the Unix sleep command, and then our test could look for an increased response time. Say if it takes 5 seconds for the test to come back, that means the sleep command probably executed. That's a better approach because it doesn't try to change any of the application state. But what about considering alternative encoding? So us hacker folks, we like to encode things in URL encoding, base64 encoding, things of that nature. So how is this test going to handle in the event that the system is decoding a base64 encoded payload or decoding URLs? We don't know the answer to that. And so there's some questions that I still have. Because when you start providing, semicolons and spaces in HTTP request parameters, it could actually break how the server's processing it. So what's the happy path? So I guess what we're asking here is we're testing to make sure that the files are not deleted, but in the event that someone uploads a file with a nefarious looking path, what do we expect to happen? So we saw this a lot with SQL injection vulnerabilities in folks that have apostrophes in their last name, like O'Brien. When we mitigated SQL injection vulnerability, we basically looked at the string and said, hey, if there's any apostrophes, like get rid of it. Well, then that suddenly doesn't work for some population of your users. So what is the happy path here? What do we expect to happen? And then false negatives. In this case, since we're deleting files, there could actually be race conditions. Tests are generally running in parallel with one another. So if this test is deleting files that another test needs, what's going to happen there? The results are kind of unexpected. So we're going to take one more test here. And what vulnerability do we think this one's testing for? I mean, I've heard some people say it. I just wish you were more confident. Yes, XSS, cross-site scripting. Anyone use Mastodon? So this is from Mastodon, the social network. So in particular, it's testing for cross-site scripting, and there's 2 test cases. We're looking to make sure it's stripping out the scripts. Scripts generally are bad. Don't want users to be able to provide scripts. So prevent rendering of scripts. So my first thought is, what if the input is lowercase or normalized in some way? So when I first saw this test, something weird stuck out to me. The script alert there on the top has a capital H in it. And my first thought is, what happens if that H was a lowercase h? Would that change our test and cause it to fail, or maybe cause it to pass in a way that it shouldn't be? So we have to understand how our application is normalizing this type of data. And then again, this is a little more subtle, but sometimes the comparison is for equality, but it should probably be a substring or a match. So for instance, we know the HTTP response is not going to equal that specifically, but the HTTP response could include that. So that's something we want to be on the lookout for as well. And are there tests for other attributes? So we didn't really talk about the second case, but the second test case says, given text with malicious classes, we want to make sure it strips the malicious classes. Okay, what's a malicious class? I have no idea what they're referring to there. But the thing that is important to me here is we're looking in particular at the HTML class attribute, but what about the ID attribute? Are we okay with users injecting ID attributes into the DOM, or should we have a test to prevent that from happening as well? Yeah, in particular, malicious IDs, is that even a concept within the application? So for what it's worth, if you're able to inject a class or inject an ID, with all these fancy single-page applications we have going on, they have event triggers that are hooked to classes, hooked to IDs. That means the attacker who's injecting the HTML could then control the flow of the application and control what the front-end user is going to see. So this is a test for cross-site scripting, which could be improved. And then again, we don't have any tests for legitimate classes. So if this was me, I would have a test for some legitimate classes there as well. So advice for designing tests. Testing is everyone's favorite thing, right? This is what y'all are waking up every day to do. No, I'm not that type of person. I don't like writing tests either. But Copilot is incredible at stubbing out tests pretty quickly for you. So if you all aren't on the Copilot bandwagon, now's the time, because it does a good job here. So first of all, make sure you're using tests. Believe it or not, a lot of the customers I work with, helping them do incident response, helping them fix their security problems, they don't do testing at all. They may have like a QA team that tests the application before every deployment, but they're not using automated testing in any way. So first of all, use automated testing. That's the first step. Make sure they're part of your CI/CD process. Then focus your test on a particular issue. If you discover a vulnerability, a cross-site scripting vulnerability, write a test for that exact case. It should live alongside the PR for the fix. And as a security engineer like myself, I would not approve your PR without seeing a test live aside it. That's a hard requirement from my perspective. And then we can get more and more fancy. We can determine ways to make the tests more reusable. So once we have a test to test for cross-site scripting, we can build out a specific harness for that, and we can use it through different areas of our application. We don't need to write the same test case 20 times. Establish tests as close to the logic as possible. This is important when you're dealing with things like file upload operations, or in particular when you're doing any sort of C or C++ native development with memory and race conditions being an actual issue. Then you want to write the test to as close as possible to the logic. And then focus, this is kind of the last step, and only if you have free time, which I'm sure all of you do. Focus on testing for permutations. So what do I mean by that? So kind of circling back to our cross-site scripting case, when we think of cross-site scripting, we could think of like different permutations of ways that that data may be provided to the server. So as is, base 64 encoded, you know, a lot of our web app functionality is base 64 encoding things, URI encoded. So there's a lot of different ways that input can be transformed. And on one of the tests we called out in particular that we don't know what happens if the data is normalized in any way. And so that's what this is trying to solve. By testing for a permutation of the data, we have a better understanding of how that data would react in many different situations. And so in this case, we just wrote, you know, a test harness that tests for all permutations of cross-site scripting. We can use that anywhere through our code base now, and we know we have a lot more substantial coverage there. So take a look at that. Again, stuff like this is easy to build out when you're starting to build your test suite, because then you can build those patterns around it. So designing for extensibility. All right. What's going on here? What's the problem with this code? I heard someone say not escaping the variable. Does anyone have any other ways to put it? So what the problem is that this is vulnerable to SQL injection, right? We know that ID, and actually, well, we know that ID is a user-supplied variable because I'm telling you that's a user-supplied variable. If you're a PHP developer, you'd probably recognize the syntax pretty quickly here. Basically, we're taking user-supplied data, shoving it into a SQL query, and bad things are going to happen. Use parameterized queries. Has anyone ever exploited SQL injection before? Ooh, nice. That's a lot of hands for exploitation. You know, 10 years ago, 20 years ago, you might have got arrested for admitting that, but look how far we've come. Okay, so another example. What's the solution here? This same query is vulnerable to SQL injection. And in the past slide, let me go back. Use the past slide, I said the solution is to use parameterized queries. Separate the data from the query, the structure of the query. What's the solution in this case? Is it parameterized queries? I'm asking questions like I can hear you all respond, and I can't hear you at all, so I'm just going to go ahead and say it. Parameterized queries won't work. In most database management systems and the drivers associated with it, you cannot parameterize the table name. So we can't simply just throw in a question mark for table name and separate the data out. That's not going to work. So what solutions do we have available? This is when we look at things like allow listing, right? We used to say whitelisting. Now we try to say allow listing. Basically, what we're talking about is taking a list of acceptable parameters and making sure the value provided is one of those accepted parameters. So in this case, we can utilize framework controls or middleware to look at the parameters and then make a decision. So what we have here in Rails is we have a before filter that says require valid table. That require valid table looks at an array or a hash of valid table names, in this case analytics, reports, and says, hey, we want a user to be able to query those two tables, but nothing else. So if the user passes in some data that doesn't exist in that allow list, we're going to raise an exception. And we're going to do that before index is ever even called, because that is a before filter. So require valid table is always going to run before that index function, which means by the time we get to line 6 and start executing that, we know that our data has been properly cleaned or sanitized, if you will. And then we're going to execute the query. Okay, show of hands. Do you think this will solve the SQL injection problem? Would you be comfortable deploying this on a Friday and then leaving for the weekend? One yes, no one else is going to answer. So I believe that this will mitigate the SQL injection vulnerability. I think this will solve the problem. But there is a slightly nuanced and better way that we can write this code. And again, remember, this is a defense in depth engineering talk. So while this, I believe, would solve the issue, this may not be the best solution. So what can we do to layer our defenses here and make our application more resilient? So subtle change coming up to the code. Before filter has been renamed to set table. And set table looks at the parameter to see if it's in that allow list as it did before. And if it is, we set an instance variable to the value of that table. And then in the index function, we are now referencing that instance variable instead of directly relying on that user supplied data. So what that means is if someone comes in and says, hey, the application's being odd, let's try commenting out that before filter that security team just set and see if it works. What's going to happen then? Well, if the before filter is no longer executed, we are going to run a query with an undefined variable, and that's going to throw an exception. It's going to break the application processing, but that's a good thing because that means our data is not being exploited, our data is not being stolen. To go back a slide, if someone comments out the before filter in this case, we're vulnerable to SQL injection again. So this is kind of a two-step mitigation to make sure that we've solved the vulnerability, but we've used that defense in depth technique to make sure that in the event that our code is reverted in some way, we're still protected. So this is a better solution. Now, obviously, we would also want to have the engineers write a test in the pull request that also verifies that we're not going to regress. So accept the reality, insecure code patterns are going to be used. All the time having conversations with engineers about needing to do things that they couldn't do and adhere to our security requirements. So be flexible, right? This is me, the security dude, telling you that we can be flexible, okay? So build an exception process. When someone comes to you and says, hey, we need to deviate away from the security requirements for this reason, support that. Build a process that allows you to support that exception. But at the end of the day, someone has to approve it. You want to make sure it's documented, and you want to revisit it. That way, 2 years don't go by, and then you're like, hey, why are we still vulnerable to SQL injection here? You have to have a conversation, and it has to be documented. But a technique I like to do now is actually annotating insecure code. So I'm sure most of you are using like to-dos, to-do annotations in your applications. I've been using this insecure annotation, which blatantly calls out the fact that the code is or could be insecure. And this will prevent someone from copying and pasting it very quickly. You're going to see that and like, nope, I'm not using that code. But moreover, I like to think at some point we could train the AI overlords to recognize that, hey, this code is insecure because someone said it is. Let's not build our models off of this code because that would be a bad example. And so again, when you're deviating away from the security requirements, focus on that exception process. And this is a case where you can do some annotation in CI to basically look at the number of insecure annotations and keep an eye on the growth of those, because you don't want your whole code base filled with insecure annotations. So building paved paths for extensibility. 10 years ago, folks fixing SQL injection would not have told you to use an allow list. They would have just kept hollering, use parameterized queries, use prepared statements, don't use allow list, don't use sanitizers. But those are paved paths that we've built to be extensible. So we're going to look at another example here. So security headers, in my opinion, are the new bank-grade encryption. 10, 15 years ago, you'd go on an e-commerce site, you'd look to see bank-grade encryption, AES 128-bit encryption. That was the marketing team trying to tell you that the website was secure. Nowadays, though, customers, they're not looking for a padlock on your website to know if you're secure. They are doing things like looking at your security headers. So security headers, what I'm talking about, things like content security policy, strict transport security, X-frame options, X-content type options, and there's a bunch of them now. But we're going to talk about content security policy. So content security policy, and I guess let me just explain very briefly that if you've never looked at HTTP headers at all, anyone out there on the internet can load up your website, take a look at the HTTP headers, and form an opinion on how you're handling the security of your website. Before I go to a new e-commerce website, I look at their HTTP response headers, and I form an opinion because I have opinions, and understand, are they going to protect my data to the best of their ability? Well, if they're not using HTTP security response headers, chances are they don't really care too much to protect my data. So anyone can go out, look, there's a website, I think securityheaders.io, where you can just put in the URL of the site, and it will give you, basically an A through F grade of the security headers for a particular website. So you should get in the habit of checking that occasionally if you want to become as paranoid as I am. So content security policy. Who here has implemented or modified content security policy before? Few folks. This is becoming a lot more common now, and I consider content security policy a security requirement. If one of our companies that we're working with doesn't have a content security policy, we write that up as a finding, because this is a very solid defense in depth technique to mitigating several different security vulnerabilities. Now, the thing is, content security policy, super helpful in reducing the risk of cross-site scripting. This alone will not mitigate the risk. So if you're using CSP to mitigate cross-site scripting, that's not sufficient. So we recommend using it. You can't use it alone. Easiest way to roll out content security policy is early in the application lifecycle. So the moment you start writing the app, if you're thinking about content security policy, chances are you're going to have an idea of how you want to handle third-party dependencies, particularly JavaScript assets, image assets, and the earlier you start wrangling this, the better. I recommend starting with a default source of self, and then you can go on and add different directives to become more restrictive as possible. And there's websites that'll help you build a content security policy for your own site. So content security policy, again, is a header, right? Now, typically, folks don't recognize that content security policy can actually be set on a per-page basis. It doesn't have to be set on the server globally. It can be unique per page. So an example I like to give is, when the marketing team comes to you and says, hey, we're A/B testing new vendors. We want more data analytics. We want to know when folks are clicking and why they're clicking. And we've got 3 different vendors we want to test. First of all, as a security person, that's my worst nightmare, because we don't want to be doing that. We value our privacy, so please don't do that. But to support them, what we want to do is we want to allow them to extend the application in a way that does this with the most minimal risk possible. So, like I mentioned, content security policy can be set per page. So you could start with one content security policy for your entire domain, and then when exceptions come up, you can add them to a particular page of your application. And we'll look at an example of this. So here's some Ruby code using the secure headers gem that allows us to configure a content security policy for our entire website. And then below, we can see ways where we are actually overriding the header and saying, hey, use this other version of the policy. So why is this important? Well, it provides the flexibility to get things done while still maintaining the most tight and the most strict level of access possible. So when we're testing these, JavaScript assets, we don't want to allow all of them on our website all the time. I don't trust these folks. I don't trust their CDNs. We don't want to give their CDNs access to execute scripts on our domain. But if we want to test them, what we can do, though, is say, we will let you test it on some particular pages, and those particular pages will give them the ability to inject their scripts. That way, the blast radius is specific to a particular page. So I want to give you all a clear example, and this is a bit of a joke because none of this is obviously clear. But content security policy was a huge thing for me and my teams when I was at GitHub. And we had a project called the GitHub README project, which allowed developers and engineers and any GitHub user to go out and share their story. And when I say share the story, I mean literally video assets. And someone on the GitHub marketing team said, hey, we want to host these video assets on github.com so users can come and view them. And we said, no, we're not doing that because we don't trust this particular CDN that you want to use for the video assets. But we came to an agreement and we said, you can do it on the github.com README page. And so on the right, or on the left, we have the github.com README page and we have my profile. And you can see the content security policies are a little bit different, and I tried to highlight that difference just to showcase that on the README page, we are supporting an additional source for image assets and a few other additional sources there. But if you go to my page, you're not going to see that. And so what that means is that someone who has compromised github.com, found some cross-site scripting vulnerability, they're not going to be able to inject it into my page in a way that would load resources from those new video assets. It's just not possible with this approach. And we built a lot of our security pipeline around exception process, so allowing users to make changes to the content security policy for the pages or the domains to which they needed to make those. And anytime someone would come in and use the secure headers configuration override, that would trigger a security rule being tripped, and then someone on my team or a similar team would come out and say, hey, we just want to make sure what you're doing is intentional. This increases the risk to our application. We're going to review it real quick and just make sure the risk is as minimal as possible. Okay, so cross-site scripting leads into XSS. And so we're going to talk about XSS, cross-site scripting. Output encoding is not a silver bullet here. So like I mentioned, as we were just talking about content security policy, don't rely on it. In fact, Mozilla themselves state that content security policy is just an added layer of security. So if you're relying on this to protect your application from cross-site scripting or other sorts of attacks, it's not going to be sufficient. This is meant for defense in depth reasons. So output encoding is still key. So most web application frameworks, Ruby on Rails, .NET, they perform some sort of output encoding by default. So when I say output encoding, we're talking about taking the HTML tags, translating them to what we consider the HTML entities variant. That way they show up on the page instead of being rendered as code or as HTML. By the way, I don't consider HTML code, but that's just a subtle difference. And so the problem here is with these solutions that are doing this automatically, there's a few situations where things are not done with respect to the context. So when I say that, what I mean is taking HTML tags and shoving them in a block of JavaScript is going to make the application respond differently than shoving HTML tags inside an HTML block. These are different contexts. HTML, JavaScript, CSS, for instance, you have to mitigate all those differently. In these frameworks, they don't know anything about the context, and so they're just taking a general stance and trying their best to use output encoding to solve the problem. And the more likely scenario is that folks are going to opt out of these frameworks. So in Ruby on Rails, you can call the .html safe method and say, hey, we consider this HTML safe and trusted, and we want to render it as it is, no longer doing any of the output encoding that the framework would be doing by default. And so for me, when I'm auditing a customer code base, spend like 3 minutes looking or grepping for HTML safe to figure out where they're using it and if the patterns are fairly secure or not. So frameworks, exemptions, those are super common ways now that we see cross-site scripting vulnerabilities still persisting. Attribute injection is a big one. So if you look at that, the P tag with the data ID attribute, shoving user-provided data in there is going to be cross-site scripting in a different context. That's the HTML attribute context. So if we insert double quotes or single quotes there, or even a space, what it would allow us to do is possibly add another attribute. So what would an example of a malicious attribute be? How about like on error or any sort of event handler that says, hey, when an error happens, like go out and run our JavaScript code. I don't know who here does .NET development, but .NET was by far the worst for attribute injection for many years because .NET had a solution called Request Validator, which mitigated cross-site scripting by output encoding it, but it only did that when there were brackets in the parameter. So any sort of attribute would not be output encoded properly and it would still be vulnerable. And the developers thought they were fine. They thought they were doing everything possible, but found a lot of cross-site scripting vulnerabilities there. And then in general, input validation is helpful, but that's not a solution. That's defense in depth, again. So like for instance, if you're expecting a user to pass in their age on a form on your website, when you're processing that data on the back end, you want to make sure you're looking at like an integer or even like a floating point value, not a string, because why would a user's age be a string? So input validation, super helpful, but that's not really going to solve the problem at all. Output encoding is still the key. We just have to recognize how to do it. So the question now is, what if we want to allow users to provide some HTML tags? Has anyone built one of these before? WYSIWYG editor? So every time I see one of these, that's how I feel. These very, very likely are going to be vulnerable to cross-site scripting. So the problem is when we want users to be able to provide some set of HTML, so like for instance, clicking on the bold, the B, that will insert a bold tag into the page, and that's going to render that bold tag as HTML. So some engineer decided, hey, we want to, well, actually, it was probably not an engineer who made this decision, but someone decided we want to support HTML. We want users to be able to customize their pages. Think of MySpace 20 years ago when you could full on like HTML flash on your website. Those were the days. But assuming you want to allow a subset of HTML, that's when things start to get tricky because you can't just take all the data and output encode it, because output encoding will break the HTML from rendering. So this goes back to our exceptions process where we know output encoding is the best thing we can do, but we can't do that in this case. We have to find an exception. So in this case, developers generally, the first step is, okay, we're going to ignore the framework's output encoding by default. And because this is tucked away, in the web interface, users going to have to click a button to change the values. It's fine, probably not going to be cross-site scripting. But it most likely would be cross-site scripting. So having a plan, start thinking about, if we want to support a set of HTML, what tags do we want to support? What attributes would we want to support in those? And then we would need to find a solution. And so the solution normally is, in this case, use a trusted sanitizer. 10, 15 years ago, if I told you to fix cross-site scripting by using a sanitizer, I probably would have been laughed off the stage. But in this particular case where output encoding will not work, using a sanitizer is the next best option. And DOM Purify. Has anyone used DOM Purify before? Oh my word. I'm going to have to ask what everyone's using for their sanitizers. So I love DOM Purify. DOM Purify, super common sanitizer in React and Angular. It's a JavaScript-based sanitizer. Plugs in super easily. If you look at their GitHub page, you'll see there's some pretty simple steps to get going. And at the bottom, you basically sanitize strings by passing in the sanitize method. Cool. Okay. Upset face. That's not as simple. It shouldn't be that simple. So looking at the README for the DOM Purify library, which, by the way, I love that library. I love the folks behind it. They do incredible things for open source. One of the first things I noticed that's weird is it says, by default, we permit HTML, SVG, and MathML. Who here is writing MathML every day? Yeah, no one. So why are they supporting it by default? What does that do to my application? What risk does MathML pose to my application? Well, I shouldn't have to think about that, right? That shouldn't be supported by default, in my opinion, but I wouldn't know about it without reading the library. So taking a deeper look at the library, we see DOM Purify by default supports and will allow 110 different HTML tags to be executed and be rendered as legitimate HTML. And then additionally, it supports 100 different attributes. So when you think of a sanitizer, you really want to think about, okay, do we need users to be able to use all 110 tags, for instance? It's too many. By the way, I'm going a little quick now just because we're running late, so these slides will be available. So I just wanted to give you one example. So in this particular case, we're calling dompurify.sanitize on some payload that I've hard-coded. Right, so it's an anchor tag with an href attribute, a class attribute, and a data URL attribute. When we call sanitize on that, what do we expect the output to be? Does anyone want to take a stab at this loudly? Okay, so someone said they expect an exception to not allow it to go through. That's definitely an option, but a sanitizer normally allows things to go through by cleaning them up. So we're looking for some output that has been cleaned up, and so let me spoil it for you. And apologies if it's hard to see, but the output is basically the same exact thing as the input. And what that means is DOM Purify allows us to use HTML tags with anchor attributes, with class attributes, and then with data attributes as well. So did not clean anything up here at all, which was surprising to me. So major takeaway here is that with DOM Purify, we know we can actually inject classes, IDs, data attributes, and more. So when we're looking at the Mastodon test cases, we saw it was testing for certain class injection. We talked about ID injection. DOM Purify would not solve those problems by default out of the box. And event handlers. And so I'm not going to have time to walk through all this now, but what I will tell you is that this, in particular, this type of flow allowed someone to earn a pretty hefty bounty from the GitHub Security Bug Bounty Program. I think this was a cross-site request forgery vulnerability that leveraged DOM Purify to invoke several different callbacks, and I think we ended up having to pay them like $25,000 for reporting this particular vulnerability to us. And so a lot of the research that I've been doing on DOM Purify has been because of some real world examples of dangers that happen even though we were using that library. And just to wrap things up, we started off talking about investigations. And now what I'm going to tell you is that DOM-based cross-site scripting, which is what was in the screenshots there, are nearly impossible to investigate because that data is never actually sent to the server itself. It's all happening on the client side. So we can prepare for investigations all day, but when something like this happens, you're not going to have the tools and techniques to investigate them. So plan accordingly. All right. And then with that, I will wrap things up now. So thanks, everyone.